Hi everybody, and welcome to this first official video of the course. These videos will be low-tech, especially at the beginning. Since I was gone and I was unclear on exactly what you were covering, I didn't make any videos in advance. I wanted to make sure they were appropriate for where we are. So this first video won't be very long because most of you still don't have, or not most, but a few of you still don't have working compilers. You haven't figured out how to get Visual Studio going. So I'm not going to introduce very much new material in the hopes that by the next time we meet or the time after, everybody's on the same page with their compilers working and we can just focus solely on programming. So for this video, we're going to talk about some arithmetic. There are a few operations that we need to talk about that are useful, and there are a few comments from class the other day that I want to clear up and make sure that everybody is clear on. So the first comment I want to make, if you recall in class, we wrote a simple little program to calculate the area of a rectangle. And the program goes like this. You create storage spaces for your width, length, and area. You get the width and the length from the user, and then you calculate the area simply by multiplying the two variables. And so this particular program here, this is just a snippet, right? It doesn't include the hashtag include IOStream or anything. In this brief snippet here, it isn't terribly user-friendly, but it does what it's supposed to. It gets a couple of numbers from the user and then calculates the area. So what I wanted to point out here that I did not point out in class is that in this line right here, this area equals width times length. Anytime you write a statement like that where you have a variable on the left and some stuff on the right, what the computer literally does is it takes this value on the right and places that value into the variable on the left. So this equals is an assignment equals. It's saying take this storage space area and inside that storage space put the value of width times length. So one thing to be very clear on is in real life you can switch sides of an equal sign. You know, if you have 2x equals 7, that's the same thing as 7 equals 2x. Right? That's true in algebra. It's not true in C++ in this situation here. So if instead you were to hand the computer width times length equals area like that, it would not know what you mean, okay? Because what it would try to do is take the value of area and place it into the value of width times length. And it doesn't know what that means. In particular, it has no value for area, so it doesn't know what to place over here, right? So when you write variable equals something, it always takes what's on the right-hand side and assigns it to the variable on the left-hand side. So you can't, in general, switch the order of equal signs in C++. I wanted to just remind you of this, that division works kind of strangely. If you're not used to it, if you divide two integers, then C++ does what is called integer division, and it doesn't record a decimal at all. So if you ask C++ to output what is 3 divided by 2, it will not output 1.5. It will output it will just output the number 1, right? It outputs an integer. Sometimes that's fine. Sometimes you really just want integer division. So if you want that, then don't worry about it. But most of the time you don't just want integer division. You want the actual number. So to get C++ to output the actual number, there are a couple of things you can do. The first is called casting. So what you're telling C++ is, I want you to think of this number 3 as a decimal, as a float. So this cout statement right here will output the number 1.5. This statement out here will also do it. If you take a number and add a 0.0 to it, you're telling the compiler that you want it to think of that number as a decimal now. And so these two statements here will output 1.5. But this first statement will not. So you need to be aware of that if you start dividing things in your program. One other thing I wanted to remind you of is that if you do multiplication, you always need the multiplication sign, right? In an algebra course, when you read 2x, you read it implicitly as 2 times x, right? But the C++ doesn't do that. It doesn't know what you mean when you write 2x. It knows what you mean when you write 2 times x. And so what you always need this asterisk there or it won't compile. It will tell you that it doesn't know what you mean. Okay, so when you start talking about arithmetic, you need to be aware that C++ respects the order of operations, just like any good computer would, right? So in this first line of code here, 2 plus 2 divided by 4, a common order of operations mistake is to say, well, 2 plus 2 is 4, and 4 divided by 4 is 1, right? So this line maybe should output 1. But of course, in the order of operations hierarchy, division has more priority than addition. So what C++ will do, it will do the 2 divided by 4 first, and since it's doing integer division, 2 divided by 4 is 0.5, it truncates off that 0.5. So according to C++, integer division of 2 divided by 4 is just 0. So C++ will output 2 plus 0, which is 2. So of course, if you want the order of operation, if you really meant 2 plus 2 quantity divided by 4, you have to include the parentheses. So just be aware of that when you start dividing and multiplying things all in the same line. C++ respects order of operations just like your calculator would. Okay, so here's a new operation. It's just called the plus plus operation. And essentially, the only reason it exists is because programmers got tired of writing this, x equals x plus 1. So again, what happens here is C++ will take the value on the right and assign it to the value on the left. So all you're doing is you're taking the value of x and increasing it by 1. So if x happens to be 1, and you do this x plus plus thing, the value of x is now 2. So if you see out x, the value will now be 2. And then if you do it again, the value is now 3. So if you see out again, it will be 3. So again, in both of these lines here, x plus plus, you could have written x equals x plus 1. Okay, but that's sort of tedious to do, especially in a long program. So x plus plus, all it does is it increases the value of the variable by 1. Okay, the last operation takes some getting used to because it's not a standard operation. It's the remainder operation, and the symbol is the percentage sign. So simply, m percentage n is the remainder when you take m and divide it by n. So here are some examples. 15 percentage 10 equals 5. To see why this is true, of course, you have to remember what the remainder is, right? So that's sort of a, fourth grade sort of thing, right? But if you haven't thought about it for a while, you'll have to remind yourself, if I take 15 and I divide it by 10, the calculator will tell me the answer is 1 remainder 5. Okay, so when you take 15 and divide by 10, you have 5 left over. And so that's what the operation will output here. If you take 25 and divide it by 6, the remainder is 1. Okay, because 24 is a multiple of 6. So what is that? 6 times 4 gets you to 24. Then you need 1 more to get up to 25. So the remainder when you take 25 and divide by 6 is 1. Okay, so in both these cases here, it outputs the remainder. If you take 6 and divide it by 3, well, 3 goes into 6, right? So there is no remainder. The remainder is 0. If you take 3 and divide it by 7, the remainder is just 3. Okay, if you take something smaller and divide it by something bigger, the remainder is just the numerator. Okay. So you might think this is kind of a strange operation, and you might be wondering why it's useful. It's useful for a number of reasons, and we'll see them as the semester moves on, but here's one key fact to note about this. Whoa. I don't know why I did that. Anyway, so if m is a multiple of n, then m divided by n has no remainder, right? N goes into m evenly. So if you take a multiple on the left-hand side and do the percentage, you get 0. Just like the 6 divided by 3 guy here, right? The 6% is 3. 6 is a multiple of 3. So there was no remainder, so the percentage operation outputs a 0. So let me just show you one quick little program that shows you that that operation in action. So this program is going to be very simple and not terribly useful, but just go with it for a second. What's going to happen is I'm going to have the user input a monetary value in cents. Okay, so they're going to give me like 420 cents or 3,000 cents or whatever. And what the program is going to do is it's going to take that cents value and divide it into dollars and cents. Okay, so if the user enters 110 cents, the program will output, okay, that's $1.10. Okay, so we're going to input a cents value and output it in the normal way of saying it, right? Dollars and cents. So I'm not going to make this very fancy. I'm not going to make this very user-friendly just for the sake of time here, but let's get the cents value in. Okay, and so how would you separate a cents value into dollars and cents? So let me just get, this amount is dollars. Okay, so if somebody gives you a cents value, how could you read off the dollar value? Well, it's actually not that hard. You just take the the cents value, and divide it by 100. And here you can actually do integer division, because you don't care about the cents, the stuff that comes after the decimal point. So imagine again that I input 110, right? 110 cents. Well, 110 divided by 100 is 1 if you're doing integer division. And that's what we want, because in 110 cents, the dollar amount is $1. Okay, so here's an example of where the integer division is fine. If I'm just trying to read off the dollar amount, I don't care about the stuff that comes after the decimal point. Okay, so I've gotten the dollar amount, and how would I read off the cents value? Well, the cents value is the last two digits, right? So if I enter 110, they're 10 cents. And so if you ever want to read off the last two digits of a number, you can just take that number, divide it by 100, and read off the remainder. Put space in. Okay, so let's see this in action. So let's run this. Oh, oops, grab my semicolon. Okay, so let's run this. So the first thing it wants me to do is enter a value, because I didn't make this very user-friendly. So let me enter in 110. And so, oops, I needed another space there. But you see it did what I wanted, right? It's $1.10. So let's run it again. You know, 312, right? $3.12. Okay? So here is a use of this percentage sign. But if I take 312 and I divide it by 100, what's left over is 12. Okay? And that's where it's getting the 12 cents from. So again, this percentage gives you the remainder when you divide value by 100. So when I divide 312 by 100, the remainder is 12, and that's what it reads off. So there's one use for it. There are other uses as well, but that's enough for now.